There's a very old-fashioned idea that intelligence is somehow fixed, as if at the moment of conception you had some number 98 stamped onto your genes. This is absolute rubbish. The brain is very plastic, particularly with young people. You can see striking differences between students who have experienced good intellectual stimulation on the one hand and those who have not. By setting the brain challenges, the whole brain develops and it gets better at doing everything.
Professor Philip Adey led research into cognitive acceleration in the early 1980s. Rooted in the thinking of Piaget and the constructivists, cognitive acceleration is premised on the idea of a set of structured challenges which accelerate students' thinking. It was developed initially in the context of science teaching and was called CASE, Cognitive Acceleration in Science Education, although it has been used in a range of other subjects as well. At the Greycoat Hospital, a girls' school in London, the science department has run the CASE programme for Key Stage 3 pupils for 15 years.
The word skills and thinking skills is one of the broadest terms used in education, and I think as time goes by, students will see less of a difference between their whole Key Stage 3 education and CASE lessons, because hopefully all subjects are reducing their instruction mode of teaching, their transmission model, and they're looking more at constructivism and saying students can take ownership for their learning, and they're just going to be much more confident learners the more we let them do that.
Initial studies in the 1980s demonstrated that CASE had a positive impact on attainment. Here we'll show you what cognitive acceleration in science education looks like in practice. CASE is a very structured approach based on a series of 30 discrete lessons taught over 2 years in Year 7 and 8. Each lesson is designed to develop students' reasoning patterns through a scientific context. Today, Tom Xavier is teaching his Year 7 group the fourth of 5 lessons about the control and exclusion of variables towards understanding fair testing.
Let's have a look at this image that I'm going to put on the board. Have a look at it. Have a look at it. Okay. What do you think? What words come into your head when you look at this image?
Fat and skinny.
Fat and skinny. Okay.
Big and small.
Big and small.
Unfair.
With each of the lessons that there are in the sequence, I've had some image that I will put up at the beginning of the lesson. And it's normally an image that I know will grab their attention. So it's a good way of grabbing them as soon as they come through the door. But also it's normally an image that I can come back to later on, after the challenge, after the discussions. Now I've got some pipes here.
All CASE lessons follow a 5-part structure known as the 5 pillars. The first pillar is concrete preparation, where pupils are made familiar with any equipment they'll be using and any terminology essential for understanding.
Now, could anybody suggest to me the variables that are shown within this group of pipes?
Could there be weights? Because some could be have more weight than others because there's big ones and there's skinny ones. So then the smaller ones could be a smaller weight than the bigger ones.
Okay, so what are the values going to be if we were going to have weight as a variable then, yes?
Light and heavy.
The first part of the lesson was what we'd call concrete preparation. And the reason why it's so important to have that there is so that later on in the lesson we start to discuss the challenge or the concept that we're looking at. We're all used to the terminology, the words that we can use, and it just means that it's inclusive. Okay, now to the challenge. So the challenge, as you can see on the board, is which input variable, so they're the variables that we've been talking about so far, has the greatest effect on the note that the pipe actually makes. So the note that I'm listening for is this one. Now, I don't think I'm going to win the awards, certainly from the music teachers, but could you hear a difference there in the note that I was making from those 2 different pipes?
Yeah.
Absolutely. Okay, so, do we understand the challenge that I'm setting you this morning?
Yes.
Excellent. Do you think you're up to it?
Yes.
Good, that's what I like to hear.
The point that we try to get across to the students and to the staff is the lesson objective is have the students experienced challenge, not have they solved the challenge, because ultimately it is a developmental process. You can't, the minute you think, well, they've all got to have got it by the end of the lesson, you're going to be instructing them.
I think it'd be best if you got a small one of one material, a medium size of a different one, and then maybe a tall one of...
to see if it's the size or if it's the material.
Yeah, that will work.
So the next stage is going to be the social constructivism part of the lesson. And it's just really getting the children themselves to start discussing, that's the social element of it, I guess, and then starting to hopefully construct a solution to the problem or the challenge that I've posed to them.
They kind of sound the same, but that was a little bit higher, didn't it?
This one, you can hear it louder because it's wider.
Social construction is primarily based on Vygotsky's work in terms of the zone of proximal development. The students here, that's where they actually are, but they have the potential to get hit to this level. And what you're trying to do is, obviously they've all got those different levels, but there'll be overlaps there.
You need people around you that think differently to you, but not too much, because otherwise you just get into an argument.
The highest pitched is the one that's thinnest and longest. Yeah. Like this one's short. What about this one?
So by actually having groups where there is a small amount of difference, but not that large extreme amount, you find that even though they might be coming at the problem from a slightly different perspective and might be describing in slightly different ways, because they're doing that, it doesn't actually halt the discussion, it actually promotes it, it actually enables the group as a whole. Okay, and why have you decided on those two?
They're exact opposites.
Right.
This one's tall.
Yes.
And this one's short. And this one's thin. And this one's fat.
How can we tell whether it's the shortness or the fatness, your words, not mine, that make the note quite low?
Should we test one? Should we test?
One at a time.
That's the same size but slightly thinner.
What a teacher needs to do with social construction is just keep asking those questions where they're beginning to construct it, but they possibly they're missing out a valuable link within it. Some people don't like the word facilitate, but it is absolutely key to the case methodology. You are facilitating, you're not instructing.
We picked these two. They're different materials, but they're the same height.
Okay, can somebody help them out? Because they've got a good idea, they want to look at one variable. So can anybody improve on this? How could we improve on the pair that we're choosing?
Could use like this one because it's the same material as this one. So you would just be looking at the how wide it is.
What hint would you give to the rest of the class in order that we can try and solve this problem by just looking at one or two more pairs?
Make sure that you're only ever comparing one factor.
One of the major things we're trying to do when we say accelerate cognitively students, we're trying to take them from one of Piaget's descriptors, which is a concrete level thinker. The easiest way of describing that is they can deal with two variables at the same time, whereas a formal operational thinker can deal with three variables.
This one because they're both made of the same material and they're the same size, but one of them's thinner.
So students will naturally mature and some will reach that, but what we're trying to do is accelerate it, so make it happen in a quicker time. That's the aim, and it's a very good time to do it. The beginning of secondary school is an excellent time to try and bring about that challenge, and I think most definitely the students welcome that challenge.
Hopefully you have got a solution for me. Before giving me the answer, can you first of all tell me a pair that didn't really help very much, and why actually, looking back now, it wasn't a great choice? Okay, hold them up so we can all see. Okay, and why, looking back, was that not a good choice?
It wasn't a good choice because we had too many variables at the same time, because they were different sizes and different widths and different materials as well.
Metacognition part of the lesson, you want them to do is you want them to just take a step back and think, well, hold on a minute, how did I actually get here? What did I actually do in order to be able to say this or that, or to be able to say with a certain amount of certainty that this is the case? Okay. Anybody want to make a comment about the choice of tubes there? Yes, Sarah.
They've both got two different variables. They're both different widths and they're both different materials, so we're testing two variables.
What we've been doing and what you have actually come to, what you've realised in this looking at this problem is that we need to keep one thing the same. When we do that in science, we call that carrying out a fair test, and it's something that we'll come back to time and time and time again.
The 5 pillars of a case lesson are often seen as the 5 parts to the lesson. For a more advanced practitioner, you start to learn that you're doing all 5 probably all the time.
Now, that's the picture that I put on the board right at the very start. Why do you think that was quite a good picture to start off with?
We've been looking at all the different variables, and you could kind of do the variables of this picture as well.
The bridging stage of the lesson, what you're doing is you're saying, hold on a minute, these skills are universal. It might be another lesson, it might be at home, it might be on the bus tonight, but actually these skills can be used time and time and time again, and they're not to be just left in the science lab. They're to be taken with you and used.
We were talking about how we could only have one variable, so that's like got at least 2 variables there, if not like 3. And so I think also that we named it a really good title because if you have more than one variable, it's really unfair.
Thank you very, very much. A lot of hard work. I'm exhausted, I don't know about you, just thinking, listening to your ideas.
It's a journey of not just constructivism for the students, it's constructivism for the teachers. We have to now construct new ways of thinking about teaching and learning. Really great lesson. Metacognition.
Yes.
How do you think you've moved on with students in terms of your questioning and encouraging that?
Well, again, I've been trying to do it throughout the lesson, so wherever there was an opportunity. When I did notice quite a big impact on other lessons, just the question and answering, the fact that I wasn't leading them as much.
Right at the end, fair test. I saw that as the only little bit where you instructed. You just then told them what a fair test was.
Yeah.
You can always say, so they weren't with you.
Yeah.
I'm just wondering what a fair test is and how you relate that to variables. Do you think, and you can always make it a question. Looking at case lessons, and we want to hear, you know, students' opinions.
Case lessons, it gets you thinking a lot more, because in normal lessons, like, you're just sitting there listening to the teacher, and it's kind of, you don't like feel like you're interacting with it. So at the end of the day, sometimes you don't really get it.
Like, it helps me more because it gives us a chance to all share our ideas together, and it's nice to know what other people think as well.
Sometimes you go home and just think about it and you try to find out more, whether it's the internet or books.
You chat with your friends about it and you might go to the library, you might have a look around or ask like some of your other science teachers.
The best learning and development happens when we recognise we don't know something, but we want to know about it, we want to sort it out. That's not what's happening primarily in other lessons. That's what's going to always make case different, because that's what we're trying to do. We are trying to challenge in quite a profound way.
We keep getting good results from it, and although you appear to be losing time to doing these odd thinking lessons rather than teaching the curriculum, in fact you gain time because the students are thinking better and they're learning everything more efficiently.